The other thing I wanted to comment on was doing substitutions backwards. I indicated this before, that when I'm setting up a substitution, often instead of using the U rule, it can be better to use a different rule, and that can be the case. Let's try an example of what I mean here. Here's a place where I have a thing on the inside that's x squared plus 1. I'd like to use that as my u. You might be tempted to use u equals x squared. Using the bigger thing is usually better. We're not going to finish this problem, by the way. Just point out how the substitution goes better. If u is x squared plus 1, can I do that substitution right now? What's du? Du is 2x dx. I might be tempted to peel off one of these x's to be used as the du. Like I can rewrite this as x squared times x times e to the x squared plus 1 times dx. And I also wish there was a 2, so I'll push in a 2 and pop out a 1/2 to cancel it. That's like a good thing to think about. But I want to say what happens if I just don't want to think about that. The alternative I have is I can take this equation and solve for x. If u is x squared plus 1, then u minus 1 is x squared. So u is the square root of that, which I'm going to write as a power of 1/2. Not u equal, I'm screwing this up. It's x equals that. When I take the square root of both sides, I get x equals the square root of u minus 1, which I'd rather write as a power of 1/2 because I'm about to take its derivative. When I do that, now I'm working out dx. What's dx here? It's the derivative of that times du. The 1/2 comes out front, u minus 1, the new exponent is negative 1/2, times the derivative of the inside. Oh, the derivative of the inside is 1, so that doesn't matter. Dx is 1/2, u minus 1 to the negative 1/2 du. Notice that this, I don't have to think about goofy, set this aside to make this part of the du. I just have a formula for dx. The other big thing is it's not clear at all. Okay, let's observe. It seems like something must be going wrong, because this formula for du and this formula for dx do not appear to have anything to do with each other. Du is 2 times x is a really simple formula. Dx is this horrible grotesquerie, like why am I getting different formulas? And now you need to say, well, wait a minute, there's a 2 on this side. If I took that equation and solved it for dx, I would get a 1/2 on the other side. And hey, look, that formula for dx does have a 1/2 on the other side. The 2 in this formula does match up exactly with the u in that, with the 1/2 in the other formula. So that part makes sense. And then the other thing to wait a minute is, hey, this is x. If I was writing x in terms of u, what would I write it as? I would write it as this. And then when I divided by it to move it to the other side, the positive exponent would become a negative. So yeah, this is saying this is 1/2, and this thing, u minus 1 to the negative 1/2, is 1/u minus 1 to the 1/2, which is 1/x, because that's what x was. These really are the same formula for dx and for du, but the fact that I took the derivative of the other side, and taking derivatives is not that bad. We got through this whole gateway stuff so we can look at functions and write down the derivatives. It does a lot of the work for you, or it can, in some circumstances. Anyway, the point is now, if I wasn't good at substitutions, I have new versions of the formula to use. And it's valuable to remember we can mix and match. I can use u equals x squared plus 1 to rewrite this thing as e to the u. And then I can use this half to say, here's my dx formula. I'll put that in for dx. 1/2 u minus 1 to the negative 1/2 du. And then what is this x cubed? It's not really obvious how to write an x cubed from here. I can just plug that thing in for x. So it's that thing cubed. U minus 1 to the 1/2. When I cube that, I get a power of 3/2. And if I'm smart, I can now combine these exponents and do whatever. And the 1/2 can come out front. Something to the 3/2 times something to the negative 1/2. The rule is x squared times x cubed is x to the 5th. That's right. I'm supposed to add these two exponents. 3/2 plus -1/2 is 1, so I get u minus 1, e to the u du. Cool, we did the substitution. We haven't finished the integral. We need the next trick for integration before we're able to do that integral. But the point is, this is another option for substitutions. When I have my formula for u, that I probably stared at the equation and stared at the problem and said, this is what I want u to be, I can often turn that into an x formula that makes performing the substitution smoother or easier or possible at all. Like sometimes it's just too hard to do it the other way, but solving for x makes it easier. And the solving for x deal makes it really straightforward because I can just plug in for all the x's. I didn't have to use u equals x squared minus 1 here. I could have plugged in u minus 1 to the 1/2. It would have ended up as u after some cancellation. Like the thing we did here is work out that if I plug this x into there, I'll get u. Yeah, anyway, that's the end of integration by substitution. You now have everything you need to do all the way through problems 29, and after that come back here and learn about integration by parts. I'll be waiting.